What is the Energy Technologies Institute and how is it helping meet the threat of climate change?
The ETI is a partnership between a number of major industrial groups, including BP, E.ON, EDF, Rolls-Royce, Caterpillar and Shell, and the UK government. And it's very much focused on developing strategic analysis and modelling capability for the UK energy system to identify what are the real challenges and the real directions we need to take for the future if we're going to meet 2020 and 2050 targets. And then having worked out those directions and challenges, we invest in major engineering and technology demonstration projects to take risk out of new energy systems for the future and make those more attractive to commercial investors.
What's been achieved to date and specifically what projects are you working on?
Well, the focus for our projects really so far has been to look at this issue around we've got to deliver low carbon energy, but it's got to be secure and it's got to be affordable. So over the last 18 months we've been running £60 million worth of projects around a number of major areas, including offshore wind, marine technologies, electrification of transport, carbon capture and storage, and small-scale microgeneration and distributed energy. And what we're really finding out from some of those first projects actually is not necessarily here is a technology which is finished and it's on the shelf ready for the market to buy, but we've been able to put down some very accurate parameters around what is going to make a good technology in this space, in offshore wind for instance, for application in UK deep water where we've got very good wind speeds, but we've really got the challenge of what does a turbine need to look like to significantly halve the cost of energy that comes off that machine. So now we know exactly the space we need to be in, and I should say we also know the space we don't want to be in for some of those things in terms of what would really not take us in the right direction. So having got that kind of engineering definition at the front end, we're now about to launch some major engineering demonstration projects in those same spaces based on that specification that we've now got.
And what about energy security?
Yeah, that's a very good point. The challenge we've got for the UK is moving forward. We've got the potential to continue to use fossil fuels in quite a big way for the future. We've got some good low carbon alternatives such as offshore wind where we've got very good resources around the UK. But the challenge we have is how do we deliver those things whilst maintaining energy security and delivering affordable energy to the customer. So a number of the projects we're working on, in fact virtually every project we're working on, is trying to achieve that balance between low carbon, yes, security, yes, and affordability, yes. And the reality is that for security in particular, you end up saying the way to deliver that is through a portfolio of energy sources and energy generation. So hence partly why we're working on quite a broad range of programs across a number of different areas. The other point I should say on security though is not just about having a mix of energy generation sources. There is an important point in energy efficiency and the amount of energy we actually use. Clearly, if I put it this way, the most secure energy is energy you don't need. So from our point of view, if we got certain programs where we're looking at that whole issue around how do we reduce energy use and energy demand in buildings and smooth energy demand out over a day and over the year to avoid us having to build very big peak generation capacity, which we don't necessarily need for the future.
What do you do with the knowledge gained?
Well, when we run a big project, such as some of the wind turbine stuff or some of the marine projects or carbon capture and storage, we generate a lot of IP in the process, intellectual property, and that comes in a whole range of styles. Some of it's patents and some of it is designs for equipment, but an awful lot of it is just in know-how and skills and training in the suppliers who are developing this capability with us. And what we're really looking to do is to make sure that those people who develop that knowledge can then use it in the market. So the last thing we want to do is develop something and then have it sitting in a filing cabinet or in a warehouse and never gets used again. We're really looking to get capability out into the market. So normally what happens with the knowledge is it stays with the people who've developed it, and that's a whole range of universities and SMEs and big corporates is the kind of people we work with, and we're then looking for them to have the opportunity to exploit that in the market and deliver that capability to UK customers.
Can you talk a little bit more about the ETI's energy systems model and why it's going to be vital for future decision making?
I said we we do this kind of strategic analysis work, which is very much focused on the whole UK energy system across power, heat and transport. So it's not just about where the next power station is going to be, but it's about where are they going to be, but what do they need to be delivering from the point of view of energy as well, and how is that going to provide power, for instance, for electric cars as we go into electrification of transport. So you see straight away power, heat and transport you've got to consider as a set, and they integrate together. So what we developed with the energy systems model was the capability to really look at the UK as a whole across those three things, but also to look at geography. Where are things going to need to be in the future? Also, very importantly, and this is the crux for the whole thing, is how do we deliver the lowest cost energy system for the UK for the future? So the modelling tools that we've developed are focused very much on just that, delivering the lowest cost options for the UK for the future. And I would stress that it's options, because there isn't any one right answer. You know, there's many ways we could reach the climate change and energy targets that we've got for 2020 and 2050. What we're trying to find, as I say, is the ones where it looks like it's going to be low cost, and then we're trying to develop the technology and demonstrate the technology to make that happen and make it low cost for the future. So the modelling tool is absolutely key to us, because it gives us that information base and enables us to target our investments in particular areas.
And what can you say about the current level of investment?
Well, from our point of view, we've currently put £60 million into projects over the last 18 months. We're in the process right now of launching another £100 million worth of projects. And each of those, to give you a feel, over the last 18 months, the average project cost has been of the order of £3 to £4 million. We expected they would go about £10 to £15 million per project over a period of time as we ramped up and got into the big projects. The generation that we're launching right now are £25 million plus projects. So we've moved very rapidly from the kind of the upfront design work, which is what many of the first projects were, around what might be a sensible technology option for the future, what does it need to look like, what kind of engineering is in it. We're now moving very quickly into the hands-on, the real tangible demonstration phases of that, which cost serious money.
And now we've seen the emergence of the Green Investment Bank to deploy large amounts of capital at scale. How do you view that?
Well, this is absolutely key for the future, because your point about deploying large amounts of capital, a lot of the projects we do are trying to reduce the capital cost on a future piece of technology. So we're trying to make it more affordable to deploy it, but nevertheless, the bill to put out 4,500 new wind turbines into the North Sea and in the Irish Sea is not a few million. We are now into billions and billions of pounds to actually achieve this. So the challenge, as I see it, is we can help put a lot of that technology capability in place up front, but then you need the markets to have access to the capital to enable them to deploy it at mass scale and to do it quickly. In terms of getting to 2020, we really have got to put out thousands of machines to actually achieve these kind of targets. So I think the Green Investment Bank gives us a great opportunity. If we can get the private sector investment in there from the point of view of capital and leverage that with government money, the opportunity then is to move very quickly from some of the technology demonstration work we're doing and get that out into the market as an offering straight away through the Green Investment Bank support.
And how important is the government's contribution here? Because there's a lot of inherent risk in.
Yeah, absolutely. The reality is we work as a partnership between the private sector and government, but the kind of technologies that we're demonstrating, if we say we're looking right now as we are at a £25 million plus next generation carbon capture separation project, we're going to be putting that kind of money into just how do you separate the CO2 effectively at lower cost and more efficiency? How do you separate the CO2 out of a gas stream? You've still got to put it into a power plant, and then you've got to worry about transport and storage underground of that CO2, which is another part of the activity that we're looking at. But you can imagine, from a private sector point of view, you suddenly realise that the demonstration of that complete chain will require hundreds of millions of pounds of investment. And in a world where right now the knowledge on storage of CO2 is very limited, We have some ideas where the sites are. We don't understand how we're actually going to monitor those sites for leakage. We're in a world where transport of CO2 through pipelines, whilst the technology's proven, we haven't installed that in the UK yet. So there's big issues around planning for CO2 pipelines and so on, in terms of planning permission, land access, all those kind of things. And then you still haven't got back to the power station where you're separating out the CO2, and there's a risk there about carbon price. And how are you actually going to get a reward for actually separating out this carbon CO2 stream and then sending it down a pipeline into a store somewhere in an oil field under the North Sea? So you can see the uncertainty in that is risk as far as the private sector markets are concerned, and makes them very reluctant to invest in even the technology demonstration, let alone the big projects. So you can start to see why the government support, both for us to work with the private sector around the technology demonstration end, but then also to work with groups like the Green Investment Bank to develop a full capital set of options for how they fund the full projects in terms of transport, storage and so on and so on. It's absolutely key to managing that risk issue, which the private sector otherwise just have no confidence in.
So do you believe that you and the companies that you represent can bring about sufficient change to bring about a low carbon economy by 2050? Is the task doable?
I think the task is doable. It's exceedingly difficult, there's no two ways about it. And if you look at any task of this scale, or on the time scale we're talking about, which isn't something we can fix or have to fix in the next 12 months, this is something that we have to work at over the next 40 years if we're going to reach a 2050 target. The real thing you've got to do to really make that happen is work out what's the right direction of travel towards 2050 from a technology point of view and a societal point of view. And having worked that out, more or less, you've got to stick to it. You've got to develop strategies, whether from our point of view, it's the kind of modelling work we do to develop the technology strategy that could take us out towards 2050 for the UK, or whether it's from a fiscal incentive point of view, which is very much the space that some of the government groups and the Green Bank type space getting into in terms of the fiscal direction we should be taking. But that's the key thing, is you've got to set the direction of travel, and you've got to be pretty consistent about staying broadly within that direction of travel. And that's exactly what we're trying to do in terms of setting up the technology direction that we need to take for the future. So that bit, I think we can do.